Okay, question 4 on paper 2, some more analytical geometry with circles. Alright, so they give us some information at the top which tells us what's in the picture. Important to notice that the y-axis and the x-axis are both tangents to the big circle. Okay, let's get into question 4.1. 4.1. Determine the equation of the circle centered at M in the form x minus a squared plus y minus b squared equals r squared. Okay, in this scenario, a and b are the center, or the x and y coordinates of the center of the circle. So let's look. If we can find the coordinates of M, then we have our a and b values. Okay, and so since this is a tangent, we know that a radius to a tangent makes 90 degrees. And here as well, a radiant to a tangent makes 90 degrees. Therefore, this is 90 degrees because that's also 90 degrees. Fantastic. So we can see that this is a flat line, so the y value of M is 1. So let's just write on the coordinates of M. So we can see the y value is 1, and we can see the x value is negative 1. Negative 1. Alright, so that's that. Then we need the radius as well. So this is a radius. So we can see from negative 1 to 0, that's the distance 1, or from 1 to 0, if we look at the y values, that's also 1. So the radius is 1. Now we can write this in our standard form for a circle. X minus a, so x minus minus 1 becomes x plus 1 squared, plus y minus 1 squared equals r squared, so equals 1 squared. There we go. That is the answer to question 4.1. Let's look at 4.2. 4.2. Calculate the coordinates of C. Okay, so the coordinates of C, this is the point C right here. And a couple of ways we could look at it. We see it's on many lines. It's on this straight line, it's on the circle, it's on the big circle, it's on this line. So we could do simultaneous equations combining any of those, but the problem is we only know one equation so far, and that's this circle. So I think the shortest way for the 2 marks that it's worth is just to use the midpoint formula for BC. So the midpoint formula, if n is the midpoint, right, because it's the center of a circle and that's the diameter. So the center is exactly halfway between B and C, the diameter. Right. So the midpoint, so n, or let's rather say the coordinates of n, negative a half and 3/2 is the answer to our midpoint formula. And our midpoint formula says we add the x's divided by 2 to get our new x value, and the same with the y's. We add the y's and divide it by 2 to get our y value. So let's do each of those separately. Let's start with the x's. So negative a half is equal to the x's added together. So we know the x value of b is 0. X value of c we don't know, so let's call it x. Over 2 equals that. Multiply both sides by 2, we get negative 1 equals 0 plus x, which means that negative 1 equals x. We can do the same with the y's. So 3/2 is equal to the y value of b plus the y value of c, which we don't know, so let's call it y over 2. Multiply both sides by 2 and we get 3 equals 1 plus y. Take the 1 over, so we get 2 equals y. Fantastic. So now we have the coordinates of C, which is negative 1 and 2. Alright, so there is the coordinates of C for question 4.2. Now 4.3. 4.3. Show that the equation of the tangent line CD is y minus x equals 3. So this is CD, that's that line, tangent to the small circle. Okay, so for a straight line we need y equals mx plus c. To find m we usually do change in y over change in x, right? The only problem is we only have one point on this line. We don't know the coordinates for d. So what else can we do? We see we have a tangent to a radius that makes 90 degrees. And when lines make a 90-degree angle, we know they are perpendicular by definition. So when lines are perpendicular, what do we know about them? We know the gradient of the one multiplied by the gradient of the other one equals negative 1. So we can use that in here. First, we need to find the gradient of BC then. So the gradient of BC equals, now we can do change in y over change in x. So C's y value is 2 B's y value is 1, C's x value is -1, B's x value is 0. So that gives us 2 minus 1 is 1 over -1. So our answer is -1. So for our gradient, we'll say the gradient we want times the gradient we have of the perpendicular lines must equal -1. Divide both sides by -1 and we get m equals +1. So far we have y equals 1x plus c. Now to find the c value, we can substitute any point that lies on our line. So the only one we have is this value, this coordinate c here. So we can sub that in, which gives us 2 equals 1x plus c. Take the 1 over and we get 3 equals c. So our equation, our full equation, is y equals 1x plus 3. But what they want is this form, so all we need to do is take the x over and we get y minus x equals 3. And there we've shown exactly what they wanted. Fantastic. Now 4.4. 4.4. Determine the values of t for which the line y equals x plus t will not touch or cut the smaller circle. Okay, so for this one, let me first draw a straight line, a nice straight line to show what we're dealing with here. So let's say we take this one, this line here. Alright, now before, let's just write down, we know we've just seen that y equals x plus 3, that's this line. So we know the y-intercept there is 3. The y-intercept here is 1, right? Okay, because we're going to use that now to just see how we can answer this question, or what this question actually means. So if we take this line, this is y equals x plus t, and in this case y equals x plus 3 specifically. But we can move it around, or the only thing that will change is the t value as we move it, because the gradient stays the same. The gradient remains 1. So at this point we see it does touch the small circle. If we move it down a little bit, we see it touches until we get to there. Then it no longer touches. So there's when t equals 1, when the y-intercept is 1. So we know that if t is from 1 to 3, it will touch or cut the small circle. Anything above 3, it won't cut. Anything below 3, it won't cut. So we can see what the answer is. And if you do something like this to explain, that should be fine. But we're going to do all the algebra to show why this works. So bear with me, this is probably going to get a little bit ugly. Okay, so first thing we need to do is we need the equation of the circle. So let's first write down the equation of our straight line is y equals x plus t. Now the equation of our circle, the small circle, we can find that by saying we know it's x minus a, so x minus half, so x plus a half squared, plus y minus b, so y minus 3 over 2 squared, equals r squared. Now how do we find the radius for this circle? Well, what I would do is I'd probably say the radius is half the diameter. So the diameter is this length. So we'll find the distance formula for that length. And we have our 2 points. So the distance formula, let's just say, I'm just going to do r in the corner here. So r equals half of the diameter. And the diameter is the length BC. You could also do NB or NC, that's fine. I just prefer not to work with the fractions, so that's why I'm doing the whole diameter. Okay, so BC, so difference between the x values, which is so -1 minus 0, so -1 minus 0 squared, plus difference in the y values, so 2 minus 1 squared, 2 minus 1 squared. So r equals a half of the square root. That gives us 1 squared is 1, 1 squared is 1, so that's 2. Half square root 2. Okay, so half square root 2 or square root 2 over 2. Doesn't matter how you write it. Fantastic, so we have our 2 equations. Now we want to find out where these are not equal. So let's put them equal and find where they have no roots. I think that's the best way to do this. So for our information we can keep in black, and then I'll write in orange our actual calculation. So we're going to substitute y equals x plus t into that equation. So we're going to say x plus a half squared equals y, but instead of y we have x plus t, not equals, my bad, plus. So plus, and then instead of y we put x plus t minus 3 over 2 squared equals this squared, right? And okay, so let me just do that. I forgot to do this. So this squared, r squared, because that's r, right? Okay, equals that squared. So this squared gives us 2 over 4, which is the same as a half. Great, so far so good. Now let's multiply out. So if we square this bracket, we get x squared plus half x is 1x, plus a half squared is a quarter. Okay, plus, and now this one I'm going to write out the bracket twice, because squaring something with 3 terms inside is a little bit more complicated than squaring something with 2 things inside. Right, equals a half. So I'm going to bring the half over so long, say minus a half equals 0. And now we're getting into the messy part of the question. Okay, we can rewrite x squared plus x plus 1 over 4, and now, so x times x, x squared, x times t, tx, x times negative 3 over 2, negative 3 over 2x, t times x is tx, t times t is t squared, t times negative 3 over 2 is negative 3 over 2 t. Okay, negative 3 over 2 times x is negative 3 over 2x. Negative 3 over 2 times t, negative 3 over 2t. Negative 3 over 2 times negative 3 over 2 is positive 9 over 4. And then minus our half, not a quarter, a half, equals 0. Alright, so that's a bit of a page full. Now let's collect our like terms. So for the x squareds, we've got one of them, another one of them, and no other x squareds. Okay, so we've got 2x squared. Now let's look at everything with an x. So we've got an x, we've got a tx. I'm just going to do with the t's, I'm going to do it at the top. And we've got a negative 3 over 2x, we've got another tx, and we've got another negative 3 over 2x. Okay, so we combine that into a tx plus tx is 2tx, and we've got x minus 3 over 2x minus 3 over 2x, which gives us minus 2x. Great. Okay, so far so good. Now let's look at what else we have. We have got everything that's not an x. So let's do the numbers. So we've got a quarter, we've got a 9 over 4, and we've got a half. So those are all the numbers by itself. So a quarter plus 9 over 4 is 10 over 4, which simplifies to 5 over 2, minus a half is 4 over 2, which is just 2. So 2, and everything that has the t's. Okay, so let's say that one. So t squared, it's the only t squared we have. And negative 3 over 2t minus 3 over 2t is negative 3t equals 0. Okay, so now it looks a little bit more manageable. Okay, let's just factorize. Let's factorize this. So first we can keep the 2x squared. Actually, let's keep the colors we were busy with now. So 2x squared we can keep. Then we can factor out an x over here. So we've got plus 2t minus 2x. Okay? And this whole part we can keep as it is because there's no x's involved. So plus t squared minus 3t plus 2 equals 0. Okay, so now we have it in the normal form, ax squared plus bx plus c, that we're used to for a parabola or a quadratic. Now what do we know about a quadratic that has no solutions? So we want to find out where this thing doesn't have any solutions, because this thing is where the two equations are equal. But we want to know where they're not equal, so that will be, when is that? That will be when the discriminant is less than 0. So the discriminant is b squared minus 4ac. So we want to say that must be less than 0. So in this scenario, this is b. So we have b squared minus 4 times a times c. That whole blue part is c. So t squared minus 3t plus 2. All of that must be less than 0. Great. We're getting somewhere. So let's multiply this out. That gives us 4t squared minus 4 minus 8t plus 4. And here we've got minus 8t squared. Minus 8 times 3t is plus 24t. And then minus 4 times 2 is minus 8 times 2 is minus 16, less than 0. Let's collect our like terms. So we've got negative 4t squared, negative 4t squared. So that's those two. Then our t's, we've got negative 8t plus 24t, which gives us plus 16t. And then we've got negative 16 plus 4 is negative 12. Negative 12. Less than 0. So to simplify this a bit, I'm just going to divide everything by negative 4. So we have t squared minus 4t plus 3. Whoa, forgot the plus. Plus 3. But now, since we divided by a negative, we have to change that sign around. Okay, great. Finally, we're getting close to the end here. So we can factorize this into t minus 1 and t minus 3 greater than 0. So now we can have our critical values. Critical values is t equals 1 or t equals 3. And now we have to draw a graph, to draw a little parabola. Oh, that's not right. Sort of like that. At 1 and at 3. And we want to know, where is this parabola bigger than the x-axis? So that'll be all of those values and all of those values, which means t is less than 1 or t is greater than 3, and that is our answer. And we see it works the same as when we looked at these straight lines, right? So if our y-intercept was greater than 3, it didn't touch this circle. Or if our y-intercept was less than 1, it didn't touch this circle. And there we have all the algebra of how we got there. Great. So there, let's move on to the next page and the next question. So 4.5. 4.5. Okay. 4.5. We're told the smaller circle centered at N is transformed such that the point C is translated along the tangent to D. Okay, so all that means is this whole circle is now moved, translated so that C goes all the way there, which means our circle would now be something like that, right? We ignore the ugly circle. So this circle is moved from there all the way to there. So if C moves, so the movement from C to D, is exactly the same as the movement from N to E. Because all the points move in the same way. So let's find what was the movement of the point from C to D. So C's coordinates was negative 1, 2, and D's coordinate is, have we calculated D's coordinates yet? No, so first let's do that. Let's first calculate the coordinates of D before we do the movement. Okay, coordinates of D, that's the x-intercept of our line. We already have the equation of the line. The equation of the line was y equals x plus 3. So now we make y 0. So 0 equals x plus 3, which means negative 3 equals x. Negative 3 equals x. So the coordinates of D are negative 3, 0. Okay, now let's look at the movement again. So from C to D, we went from negative 1, 2, all the way to negative 3, 0. So for the x values, we went from negative 1 to 3, so that's minus 2. For the y values, we went from 2 to 0, so that's also minus 2. So this same translation we want to apply to the point N. Okay, so the point N to e, we want to apply the same thing. So n was negative half 3 over 2. So we want to apply the same translation as this. So x will be minus 2. So negative a half minus 2 gives us negative 5 over 2. And 3 over 2 minus 2 gives us negative 1 over 2. So that is the coordinates of E. Alright, that's E. And finally, question 4.6. I know it's been quite a ride so far, especially that question 4.4. 4.6. If it is given that the area of quadrilateral OBCD is 2a squared, so OBCD, so that's this whole shape, that whole shape. So if that area is 2a squared, then we need to show that a equals square root 7 over 2. And they tell us that a is also positive. So this is our information. Now, I think the best way would be to just go calculate the area of OBCD and set that equal to 2a squared. Okay, let's do that. So what I think I would do is I would split this up into a couple of different shapes. I would do that shape and that shape. So now I've got a square and we've got two triangles. Okay, so for this little part, I'm somehow going to write in here. So this square, its length, like side 1 times 1 will give us 1. This triangle, it's half times base times height. So this height is, we know that the y value here is 1, the y value there is 2, so that's a 1, that's a 1, so 1 times 1 is 1, and half of that is a half. Half times base times height gives us 1 over 2. This one we can do half times base times height as well. The coordinates for D we know is negative 3, 0. So this distance is from negative 3 to negative 1 is 2, and the height is also 2, right? This height, 2. So half times base times height gives us 2. Now we just add all of that together. So we get 2 plus 1 plus a half. That gives us 3.5 or 7 over 2. I just want to like writing as fractions. But we know that they also said the area is 2a squared. So 2a squared equals 7 over 2. Okay, divide both sides by 2. Then we get a squared equals 7 over 4. And take the square root. So we take the square root of both sides, which will give us a equals square root 7 over 2, plus or minus. But they told us a is bigger than 0, so we can ignore the minus. And that is then our answer. Great. Well, thank you for joining me for question 4, and be sure to check out question 5 as well.